Hello everyone, this is the first lesson of Chapter 8, Adding and Subtracting Polynomials. In this video, you will write polynomials in standard form as well as add and subtract polynomials. So let's look at several vocabs that you will learn in this lesson. The first one is a polynomial. A polynomial is a monomial or a sum of monomials. When you have sum of two monomials, it's called binomials. If you have sum of the three monomials, it's called trinomials. Polynomials with more than three terms do not have special name for it. Also, you'll be asked to find degree of monomial. Degree of monomial is a sum of exponents of all its variables. So for example, let's say you have x, y to the second power. This is monomial in product of two variables. In this case, the x has the exponent of 1. Thus, the degree of this monomial will be when you add the exponent. So 1 plus 2, I'll get 3. That's how you find the degree. However, if you're looking for the degree of the polynomial, this is the same as the degree of monomial, except you have to find with the highest degree. You'll be also asked to write in standard form of polynomial. I know that you have talked about the standard form in many different lessons. However, in this case, they're talking about for you to arrange your monomials from the greatest degree to the least degree. So here's the first example. Determine whether each expression is a polynomial. If so, identify the polynomial as a monomial, binomial, or trinomial. Then find the degree of the polynomial. So let's look at the first example. 3x minus 7xyz. Is this polynomial? The answer is yes, it is, because this one has sum of two monomials. It's called binomial. If I want to find the degree of this polynomial, then I need to look at the degree of each monomial and find which one is the highest. The first term, 3x, where I have 1 as the exponent, so my degree is 1 on this one. Where this negative 7xyz has 3 as their degree because each variable has 1 as their exponent. So 1 plus 1 plus 1, I'll get 3. The highest degree on these two terms will be 3. The next one, negative 25. This is also a polynomial because it is a monomial. Monomial is also a polynomial. If they are asking you, is this monomial, binomial, trinomial, as I just mentioned, it's going to be monomial. If I want to find the degree of just a number, well, the thing is I don't have any variable next to this negative 25. So if you remember the rule of exponent, there will be still a variable. Let's just pick any variable. I'm going to call it x. This one has the exponent of 0. Because anything to the power of 0 will become 1. Thus, my degree in this case will be 0. The third one, 7n to the third power plus 3n to the negative fourth power. Is this a polynomial? Well, in order to be a polynomial, you need to have either monomial or sum of the monomials. This one, 7n cubed, could be monomial where 3n to the negative fourth power is not monomial. The reason is because it has a power with negative exponent. Also, if you write the negative exponent with a positive exponent, it will become 3 over n to the fourth power. So this is not monomial, so there's nothing you can say. For the degree wide, because it's not polynomial, there will be no degree as well. The last example that I have is 9x cubed plus 4x plus x plus 4 plus 2x. Each term could be defined as monomial. Now, only thing is later you will need to simplify this. So 4x plus x plus 2x. They are all like terms, so you can write as 7x. Eventually, you will have three terms. So in order to determine whether it's going to be monomial, binomial, trinomial, you can say I'm going to have trinomial because I have three monomials. Now, the degree of this form will be looking for the highest degree of monomial. So in here, by looking at it, 9x cubed has a degree of 3. 7x has degree of 1. The 4 has degree of 0 because there's a variable next to it, and I'm assuming x to the 0 power will become just 1. So my highest degree is 3. Let's look at another example. Part A, state whether 3x squared plus 2y plus z is a polynomial. If it is polynomial, identify it as a monomial, binomial, or trinomial. So to decide whether it's going to be polynomial or not, let's look into each monomial to see if they can be identified as monomial. The first term, 3x squared, is a monomial. It is the product of a number and a variable with the exponent. The second term is also monomial. The third one is monomial as well. So because this expression is written as sum of monomials, it is, yes, it is polynomial. And because I have three terms or three monomials, I'm going to say it is a trinomial. Part B, state whether 4a squared minus b negative second power is a polynomial. If it is a polynomial, identify it as a monomial, binomial, or trinomial. So in this case, let's review one more time. 4a squared is a monomial because I have a number with variable multiplied to each other. This negative b to the negative second power is not monomial because when you have negative exponent of the variable, this becomes b over n to the second power. And when you have a variable on the denominator, we do not call it as monomial. So thus, this becomes, no, it is not polynomial. The part C, state whether 8r minus 5s is a polynomial. 8r is a monomial, minus 5s is also monomial. So I'm going to write this is a polynomial. And to be more specific, I need to identify how many terms there were in polynomial. And in this case, there are two. So 2 is bi. So I'm going to write binomials. Example number 2, part A, write 9x to the second power plus 3x to the sixth power minus 4x in standard form. Identify the leading coefficient. The standard form is for you to write a polynomial from the greatest degree to the least degree. By looking at these three terms, it looks like 3x to the sixth power will have the highest degree as of 6. That one goes to the front, and then I have the second highest degree, 9x squared, and I will write the last one, negative 4x. So this is a standard form. I have the highest degree to the lowest degree. Now, when they're asking you to identify the leading coefficient, just in general for the coefficient means the number in front of the variable. In this case, when I call it as leading coefficient, I'm looking for a number that's very at the front. So in this case, my leading coefficient is equal to 3. Here's the next example, part B. Identify the leading coefficient of 5m plus 21 minus 6mn plus 8mn to the third power minus 72n to the third power when it is written in standard form. This is not written in standard form, so we are going to rearrange this from the highest degree to the lowest degree. Now, this 5m has a degree of 1, 21 has degree of 0, negative 6mn has degree of 2 because I have 1 for m, 1 for n, so the sum of those two exponents, it becomes 2. 8mn to the third power will have degree of 4. The negative 72n cubed will have degree of 3. The highest degree will be 8mn to the third power. The second one will be negative 72n cubed minus 6mn plus 5m plus 21. This is a standard form of this polynomial where if I want to find the leading coefficient, again, leading coefficient is when you write in standard form, what is the coefficient of the first term? So in this case, the 8 will be your leading coefficient. I'm just going to write LC. In order to add and subtract polynomials, this is a similar concept of when you learn like terms. So like terms are monomial terms that are either identical or differ only in their coefficient. For example, 3p and negative 5p. They both have variable of p with the same exponent where their coefficient is slightly differ from each other. So 3 minus 5, you will get negative 2, and at the end, you will just put the same variable. Another example is 2x squared y and 8x squared y. Both term has x squared y, which is different coefficients. So eventually, if you are adding them, you'll be just looking at the coefficient. 2 plus 8 will become 10, and you put x squared y at the end. The third example of this lesson will be adding polynomials. For example, 7y squared is a like term of 5y squared. So if I add them, 7 plus y, I will get 12, and you just write y squared at the end. 2y has a like term of negative 4y. So 2 plus minus 4 will be same as 2 minus 4. So I will get negative 2. and then you put the y at the end. Negative 3 plus 2 will become negative 1. This is the simplest form that I could get, so this is going to be my answer. Let's look at the second example. 3x squared, negative 5x squared are the like terms, so if I add them together, I will get negative 2x squared plus 2x plus 3x. This 2 becomes plus 5x. Negative 1 plus 4, I will get plus 3. This is the simplest form, and it is actually a standard form as well. Example number 4, subtracting polynomials. In this case, just be careful when you're subtracting that you're subtracting the whole terms inside of the parentheses. 6y squared has a like term with 2y squared. So when you're subtracting 6y squared minus 2y squared, I will get 4y squared. 8y to the fourth power has a like term with 9y to the fourth power. So 8 minus 9 will become negative 1, and then y to the fourth power. You don't have to write 1 in the front if you don't want to. Negative 5y minus negative 7y. So this is the part that I want you guys to be careful. Negative 5y minus negative 7y. In this case, minus with a negative will become positive, so it becomes plus 2y. As you see, it is not in standard form. I know that they didn't really ask you to write in standard form, but if you want to practice, you can write it as negative y to the fourth power, and then the second largest will be plus 4y squared plus 2y. This will be my answer. Part B, in this case, 8y to the fourth power has a like term with 6y to the fourth power. 8 minus 6 will become 2y to the fourth power. 3y squared doesn't look like I have any other like terms, so let me just copy that down, plus 3y squared. The constant negative 2 minus positive 9 will become just negative 2 minus 9, so I will get negative 11. The term that you haven't done it yet, so that's why I like to underline or cross it out, some terms that I have done, so that I don't forget or I don't leave anything left out. This time you will just have negative 5y cubed. Let's rearrange them so it will look a little bit nicer in standard form. So 2y to the fourth power, and then I will write this negative 5y cubed, the third one, plus 3y squared minus 11 will be my answer. Real world example, the profit a business makes is found by subtracting the cost of produce on item C from the amount earned in sales S. The cost to produce and the sales amount could be modeled by the following equations, where X is the number of items produced. Find an equation that models the profit. So they were saying in order to find the profit, you are going to subtract the cost C from the S. So when I'm doing this, you're going to subtract C from the S. S minus C is what we are looking for. So let's subtract these two terms. So I have 150x squared minus 100x squared. These two will become 50x squared. 450x minus 500x, this time it will be negative 50x. 200 minus negative 300, so 200 minus negative 300 becomes actually 200 plus 300, I will get 500. This will be your equation that they are looking for. One more example, part B. Use the equation 50x squared minus 50x plus 500 to predict the profit if 30 items are produced and sold. So this was the equation actually that we found from part A, and now they're saying that using this information, if I give you 30 items, how much will it be? So the X was representing the number of items, where we're going to plug 30 into each axis. So in here, I will have 50 instead of X, I'm going to write 30. And of the 30, you need to square them. Minus 50, and then instead of X, I'm going to put 30. And then the last number, 500, doesn't change. This is just constant. So 50 times 30 squared. 30 squared will become 900. So 900 times 50, I'll get 45,000 minus 50 times 30. So if you are struggling, try this way. 5 times 3 will give you 15. The last zeros will be just added to your number. And then plus 500. When you're simplifying all this, it will equal to 44,000. And I'm assuming these are the costs, so I'm going to put $sign, so it's $44,000. This is the end of the lesson. Thanks for learning with me. If you have any questions or suggestions, please don't hesitate to leave a comment.